Today we're going to talk about Unit 3, Day 3 homework. We're going to nail these geometry proofs. So the first clue that we have is that AB is perpendicular to AE and CD is perpendicular to CE. So that's going to tell me that I have a right angle at angle A and a right angle at angle C. When I say that the E is the midpoint of BD, I know that BD is getting cut in half, telling me that BE and DE are congruent. My third fact is that AB is congruent to CD, and I don't need to explain a whole lot about that. My goal is to prove that triangle ABE is congruent to triangle CDE. So the first thing I'm going to do in my proof is I'm going to write my givens. So AB perpendicular to AE, CD perpendicular to CE, E is my midpoint of BD, and AB congruent to CD. So I'm writing down my givens. I've marked up my diagram. Now I'm ready to dive into my proof. So number 2, the first thing we knew from our clue was that angle A and angle C are right angles. And the reason we knew that was because perpendicular lines form right angles. Now, once I know that they are both right angles, I can then say that angle A is congruent to angle C. And I know this because all right angles are congruent. Now, looking at my proof, I know that I'm going to have a situation where I have angle side side. And I know angle side side is not a valid method of proving triangles congruent, but I do recognize that I have a right triangle. So I have triangle ABE and triangle CDE are right triangles. And I know they're right triangles because they are triangles with one right angle. Now I'm going to go on to my next clue. And my next clue told me that E was the midpoint of BD. And since I knew it was the midpoint, I then can conclude that BE is congruent to DE. And I know that because midpoints create two congruent segments. Now, with all of that information together, I can now conclude that triangle ABE is congruent to triangle CDE. And my congruence criteria for that is hypotenuse leg. So I know that I've now proved those two triangles congruent. Question 2. Similar to my last proof, I'm starting off with AB being perpendicular to AE, telling me that I have a right angle. I also know that DE is perpendicular to EA, giving me another right angle. I then know that C is the midpoint of AE, telling me that my two segments are congruent. And I also know that BC is congruent to DC. So again, I'm in a situation where I have a hypotenuse, I have a leg, but this time I'm not proving triangles congruent, I'm proving angles congruent. So I'm going to finish writing my givens. So step 1, I know this is true because it is all given to me. Now, very similar to my last proof, I know that angle A and angle E are right angles. And I know that because perpendicular lines four right angles. Once I know that they're right angles, I now know that angle A is congruent to angle E because all right angles are congruent. Now, again, I know that I'm going to be using HL as my congruence criteria, so I do need to say that triangle ABC and triangle EDC are right triangles. And I know that because they're triangles with one right angle. I'm going to then talk about my midpoint. So I now know that AC is congruent to EC because midpoints create two congruent segments. I know that my triangles are now congruent. So I'm going to say that triangle ABC congruent to triangle EDC. And I know that because of my HL theorem. And now that I know that my triangles are congruent, I can say that angle B is congruent to angle D. And since my triangles are congruent, I know that all of the corresponding parts of congruent triangles are congruent. Right, moving on to, I'm going to have you do number 3 on your own, and I'm going to skip down to question 4. So question 4, we're proving something that we have not had to prove before. We are now trying to prove that my lines are parallel. So starting off with my given information, I have that AB is perpendicular to BC. So I know I have a right angle here. CD is perpendicular to DA, so I have another right angle here. I also know that AB is congruent to CD. So right now I have 2 key pieces of information, and I will use my third piece of information by looking at my picture, and I will use my reflexive property since angle side AC is congruent to itself. So I'm looking at another situation where I have hypotenuse line. I then want to pull the pieces that I want out of the triangle to try to prove that AB is parallel to CD. So what we're going to do is we're going to try to pick out angles that we know will help prove that my triangles are congruent. Then we'll show what parallel lines have. So I'm going to start off with my givens. I have AB perpendicular to BC, CD perpendicular to DA. I also have AB congruent to CD. All right, so let's start off with our right angles. So angle B and angle D are right angles. I know this because perpendicular lines form right angles. I then know that my 2 angles are congruent to each other because I know that all right angles are congruent. Since I know I'm going to be using HL, I do want to state that my triangle ADC and my triangle CBA are right triangles. I know this because they are triangles with one right angle. So now moving on, I do need to state about that third side of the triangle there. So AC is congruent to AC, and that's my reflexive property. I'm now ready to prove that my triangles are congruent, and I can prove that those triangles are congruent by using HL. So number 6, triangle ADC, congruent to triangle CBA, and my reason is my hypotenuse leg criteria. Now I'm trying to deal with what is going to make my lines parallel. So when I look at the sides that I want parallel and I think about cutting with my transversal, what I want are these two angles here and here. So I'm going to say for step 7 that angle 1 is congruent to angle 2 in my picture. And this is because corresponding parts of congruent triangles are congruent. Now, since I know that, now I have my alternate interior angles, and since my alternate interior angles are congruent, I now know that AB is parallel to CD. So, my reason, I've got lines cut by a transversal with congruent, alternate, interior angles are indeed parallel. And that's the end of my proof. Hope this was helpful and have a great day.